Hello, ladies and gentlemen of chemistry. Today we're looking at moles, measurements, and math. These topics cover page 1, 5, and 11 of our final exam review. Couple things to keep in mind. Conversion factors can multiply by or divide by various units in order to get an answer in the units you want. If you want a certain unit on the top of your fraction, you're going to put it on the top when you multiply. If you want it on the bottom, you're going to put it on the bottom. Now to get rid of units, if it's on the top and you want to get rid of it, you're going to multiply by that unit on the bottom of the fraction, which means to divide by it. To get rid of a unit that's already on the bottom, you're going to multiply by that unit on the top. Some units you'll see often in the gray box here: mass is measured in grams, volume in milliliters, density in grams per mil, molar mass in grams per mole, and Avogadro's number is a number of items, such as atoms or molecules, per mole. Some common problem types in the teal box. For molar mass, you're going to add up the molar mass for each atom to find the compound's molar mass. So if you have, let's say, water with 2 hydrogen atoms and 1 oxygen atom, you're going to take the molar mass of hydrogen times 2 for the 2 hydrogen atoms plus 1 oxygen atom to get the molar mass of water. For percent composition, you take one of the elements in that compound, for example, the hydrogen, take the mass of all the hydrogens, and divide it by the mass of the total compound, H2O, times 100%. And for density problems, you're typically dividing the mass in grams divided by the volume in milliliters. If it's arranged differently, you can use your conversion factors. Okay, to calculate the molar mass of ammonia, we're going to take our molar masses from the periodic table and add them up. We have 1 nitrogen. That's going to be 14.01. I'm rounding to 2 digits, which is how your periodic table typically shows them. Hydrogen is going to be 1.01 times 3, which is going to give us 3.03. Add them up. Get 17.04 grams per mole. Okay. To calculate the percent composition of hydrogen in an H3, we're going to take the total mass of the hydrogen and divide it by the mass of the total compound, and then we're going to times 100%. So the mass of the hydrogen is 3.03. We're going to divide by 17.04 and then times 100% is going to give us our answer. So if I pop that into the calculator, I get 17.78%, which I would round to 17.8% since I only had 3 significant figures. Okay, it'll be a multiple choice test, so you'll be able to find the correct answer if you're within rounding distance. On page 11, we had an example of glucose. We already had found the molar mass at this point. It's 180.16 grams per mole. If I want to know how many moles are in a gram sample. So my answer is, is in moles. I have grams to start. Here's where we use a conversion factor. I want grams on the bottom so they cancel out. I want moles on the top because moles are what I want. So I have 180.16 grams per mole. That means I'm going to put the 180.16 on the bottom for grams per 1 mole. Okay, so I'm going to take 55.5 and divide it by 180.16. I get 0.308 moles. It makes sense that I have less than 1 mole because look, I had 55.5 grams, which is less than the number of grams in 1 mole. So there's our answer. Remember to keep units in mind whenever you're working on these problems. All right, for density problems, keep in mind again the conversion factors and that the units of density are grams per milliliter. Find the density of X grams of liquid if it takes up Y milliliters in volume. Since we want our answer to be grams over milliliters, we're going to put X grams on top divided by Y milliliters. So whatever numbers they gave you in the problem, you would put where the X and the Y are, do the division in your calculator, and you'd get the answer for your density. Okay, now for this problem, we want to find the volume. Volume is equal to milliliters. So we know we're going to want milliliters on top. So we have Q, grams per milliliter, and P grams. So let's put the grams first. We have P grams times, I said that to get rid of a unit, like grams, we want to put it on the bottom to get rid of it like that. And milliliters are the units we want. So Q is grams per milliliter. The Q has to go down where the grams are and put a 1 on top. Okay, so we would have P divided by Q, milliliters, would be our volume. Now you can rearrange all this with algebra if you want. You can use density equals mass over volume, and then rearrange that to get whatever density problem you want. But if you just use the conversion factors and you know what units you want, you can do what I've done here to make it turn out as well. All right, work on the rest of the problems. I'll be happy to answer any questions about them on Wednesday briefly before we move on to those topics. Happy studying!